Okay, today what we have is we have a goal and it says I will use the annuity formula to calculate the amount of a future investment. Okay, so what on earth is an annuity? Okay, no, I did not make up the word. So, amount of annuity. So, first of all, when we're talking about this, an annuity is a series of equal payments made at regular intervals. So it's not something that I'm investing one time. It's a series of equal payments made at regular intervals. The payments are made at in most cases, we're going to say at the end. Okay, there are other ways that we can do it, but we're going to do it at the end of each compounding period. Now, the amount of the annuity is the sum of all the regular deposits, so all the money I've put in, plus any interest I've earned. So it makes it harder in a sense that I'm investing money at more than one time. And at the end, I get all my deposits, obviously, plus any interest. But what happens is the money that I put in at the beginning obviously is going to get more interest than something that I put in tomorrow. So let's take a look at, we're going to examine how this actually works. So we're going to take $450 and we're going to deposit at the end of each quarter. And remember, quarter is going to be four for 1.5 years in an investment account that earns 10% per year compounded quarterly. Okay, so couple of other things. The depositing time, okay, so 4 times a year, and compounded quarterly. So those two have to match up as well in order to use this formula. Now for you, in this course, they both will match. So let's take a look at what we're talking about. We're going to calculate our I first of all. Now we know that our I is our interest rate per compounding period. So we have 10% compounded quarterly, so that's why we have to divide it by 4. And when we do that, we actually get decimal 0.025. Now our n, well, our n is going to be 1.5 years, 4 times each year, and that is 6 times. Now, the reason, and that's why we have a star here, I can't use the compound interest formula because using the compound interest formula will not work because $450 is added each quarter. Okay, so I could use it if I was only doing one $450, but I keep adding another $450 each quarter. So that's why it's not going to work. So as you can see, you have a table in front of you. Okay, and so what's happening with this table is we have our quarter. And remember, I'll tell you about that in a minute, but we have a quarter, we have our starting balance, the interest earned, and then we're going to deposit 450. Okay, so at the end of the first quarter, we're depositing $450. The start of the second quarter, what's going to happen is we have $450, and if I use P, which is our principal, 450, times our 0.025, and our time is 1/4 of the year, we end up that we have made $11.25 for that quarter. What has happened then, at the end of the quarter, I go and add another 450. So now what's happened, I had my original 450, I'm adding another 450, so now I'm at $900, but I've also made $11.25 in interest. So now I have $911. So in the next quarter, the third quarter, that is the amount that's invested. And the interest that I earn on that is going to be $22.78. So notice it has gone up more than double. And at that end of that quarter, will add another $450 deposited. So what's happening is each time I'm adding $450, that becomes my new investment. I get interest off of that for the fourth quarter, and then I go and add another 450. So what happens each time is you can see the reason these numbers are increasing greatly is because we keep adding 450. Okay, so again, we have this amount from our previous end balance. I'm going to make $46.72, add another 450. I have a new amount. That new amount's invested. I get interest off of it. And finally, what happens is I add another 450 and I end up with my final investment. So what's happened here is this first 450 made 1125. And I've added how many 450 cents then? One, two, three, four, five. So normally you would think that you could take that amount, right? And if you multiply it by this, you would you get 59? Well, you would get 55. I'm getting 59. So you can see that it doesn't work out exactly the same way as if we were just using the compound interest formula. So what this means is the amount of the annuity is going to be this amount here, which is 2,874.48, and the amount of interest. Well, the amount of interest that we would do is we would add all of this up if we wanted to, and we would find out that we had $174 if we calculate it, if I added it correctly, which I believe I did, $174.48. Now, if I didn't have this column here, but I only had the ending balances, we could actually figure out how much that we actually made in interest as well. And the way we could do that has to do with this formula here. Remember, we have the amount is principal plus interest. So in this case, the amount is going to be the interest is going to be the amount minus the principal. Well, what was our principal? Well, that would be if I added the $450 six times. And if we do that, you can see that we end up with the 28 minus $2,700. And when we do that, we also get our $174. Okay, obviously, that was only, using that table, was only for a year and a half. So you can see that if I was investing something for, even 5 years and I kept depositing money into it, I would have quite a long table and it would take a long, long time. So what's happened is we developed a formula for that, and that's what we're going to look at here. So this is called the annuity formula, and you can see it's quite the monster. And let's take a look at what those variables stand for. So we have A is the amount in dollars, so that's our final amount. R is what we call the regular payment in dollars. So that's our regular deposit that we're putting in. And it has to be, in this case, 450 each time. Or if you're just doing $100, it has to be $100 each time. You can't change the amount. I is our interest rate, again, per compounding period, so we have to divide, and N is the total number of compounding periods. So let's take a look at that last question that we just did using the table, which took us almost 8 minutes to do, and actually calculate using the annuity formula this time. So if we kind of go back and look at that picture now, because you have the question on another sheet, you can actually go look at it. So what we're doing here is we're finding our A. Our regular deposit, they told us, was $450. And our interest rate, and we actually calculated it as well, was equal to 0.10 divided by 4, which I believe was 0.025. And then our N was, we were doing it for 1.5 years and quarterly, so that meant 4 times. And because this was in years, I can also multiply it by 4 times a year, and I end up with a 6. So we're going to take all that information, and you'll see that it is actually much, much faster to do it this way. Now, obviously, you have to be very cautious with your brackets. Okay, all scientific calculators have brackets. If you're using the graphing calculator, it's a little bit easier because it actually shows you them. Some of the other ones aren't quite as nice, as user-friendly. And then we're going to divide that whole thing by the 0.025 again. And when I do that, I end up magically with $2,874. Oops, it just disappears. That's just the way my money disappears sometimes. And $48, 48 cents. Okay, so you can see that it was a lot less time consuming doing it this way compared to a table. So this formula allows for you to make regular deposits. So what you're going to do now is you're going to actually play with this formula a little bit. And tomorrow you also will look at this formula. Plus, we'll also look at a different way that we can do things as well. Okay, so have some mathematical fun.